All right, we're ready to start. Hey everyone, last day, right? Oh, sleep, okay. My name is Timirah James. I am a developer advocate for Platform9 systems. I work alongside Erwin on the Fission team. Fission is Platform9's function as a service that is built on top of Kubernetes. We'll talk a little bit more about that later on in the talk. But today's topic is function composition in a serverless world, right? So throughout this talk, we'll, of course, go over what function composition actually is, why it even matters, and then we're going to give a couple of examples of a few composition styles and some benefits and takeaways for each. First, just as a protocol, I'm just going to go over what FaaS is. FaaS, of course, is functions as a service, and FaaS frameworks allow developers to deploy individual parts of an application on an as-needed basis, right? So there are a couple benefits here. One, that it's super developer-friendly in the way that it strips the obligation of having to manage or maintain servers. Also, it's a pretty great billing model as you only pay for the resources that you actually consume. And also, when you're using FaaS frameworks, scaling is simplified. So now what is function composition? In my own words, I like to say that function composition refers to the concept of creating super function combinations, right? So all you're doing is taking these smaller functions and using them to create these bigger, more complex functions in efforts to just gain more efficient and sophisticated functionality. Now, the way you compose functions actually plays a key role in just how your functions are deployed, right? In terms of latency, in terms of resource usage, in terms of course, resource usage ultimately results in cost. And overall, just the responsibility that you have as a developer as it pertains to the success or the failure of your functions overall. So we're just going to use a pretty cute, simple application for our example use case. We just have an application that sends a photo to a third-party image recognition API, and it's going to grab the first generated tag and convert that text from English to Danish. So they're split into two functions. But can we combine both functions into one service? And the answer is just simple. Of course. Of course we can do this. So the next section of this talk is pretty much going to go over how we can do that, right? So there's several ways that we can go about it. I'm just going to go into several of those styles and some why you might want to go into those styles and why not. The rundown, we've got manual compilation, direct or chaining, coordinator functions, event-driven, and workflows. So just diving right in, probably the easiest way to combine functions is to just do it on a source code level. Now, but when you do this, and you use a FaaS framework, that FaaS framework is going to recognize those functions as one big task, right? So it's not going to recognize them as their separate tasks that they should be. It's going to recognize them as one. And I'm going to point out why that might be a problem. This is just in perspective. On the right, you just have some pseudocode over there. And we have our two functions, which is, the image recognition and then the translation of the text. And then we have a function at the bottom that just calls both at once, right? Pretty simple. Pros of this, again, you can do this at a source code level. You really actually don't need a FaaS framework to do this. There's no serialization overhead. The cons, of course, with anything, is the bigger the function, the slower the load time may be. And also this one con that I actually want to point out is the inability to be able to scale these functions independently. You actually lose out. This is just more so as a caution, right? So even though you've merged these functions together, they're still two individual tasks. So each function, they're still using X amount, their own amount of resources, their own amount of memory, their own amount of CPU. And so when you're thinking about a case in which you want to, there's a request being made that only requires one of these functions or a portion of the functionality, because the FaaS framework recognizes both of these functions as one, you're kind of defeating the purpose of the main benefit of FaaS, is that you're only supposed to pay for what you consume, and so you're consuming double the resources. The next one is direct or chaining. You may or may not have seen this. This is pretty common. And basically, this is where you just combine your functions in the form of a chain. So the functions are kind of nested within each other. Each task is a separate FaaS function, but they're completely aware of what comes before and after it. Just in perspective, we have our code, and you see they're separate. And the only difference here is that there's an HTTP call being made to the next function, right? If we look over to the left, function A is making that HTTP request to function B. It's sitting there, it has to wait for the response, and then once it gets the response, then it actually ends and then sends a response back to the client. Pros of this, you can do this yourself. You really don't need any external components. No serialization overhead, but the cons can be a little bit costly depending upon your project. Each function waits for the next function, right? So could be wasting time, could be wasting resources, wasting money. And also another con is what Erwin likes to call operational complexity, right? So now you become responsible. You have to think about, things like handling failures, things like, fallbacks, retries. All of that kind of falls back on you, which leads me to the next con, which is the pain of having to update an individual function. So if each function is dependent upon the one prior to, the one next, the one after, then imagine if you had to make a major update to just one function. So major concern there. The next one is coordinator functions. So this is where you create an additional function that essentially acts as a director or a coordinator, and has this omniscient ability to kind of know the full sequence of functions, right? So it manages the full execution flow. So this is similar to direct functions, except each function is unaware. So direct functions, hey, I know what's coming after. It makes the call automatically. Each function within this flow is unaware. It just comes when it's called. So this is essentially what it looks like conceptually. You have your additional coordinator function. Request is being made to first function. Once that response comes back, the request is being made to the next function. The response comes back, it ends, and sends the response back to the client. This is great because you don't need to modify the primitive functions. Also, it gives you a little bit more control. You can manipulate the control flow. You just basically put all the instructions within the coordinator function. Cons of this, you have to create the additional function, right? So it's a little bit of cost. Also, you have to think about the fact that, okay, so the coordinator function, we're going back to the sequence here. So the coordinator function is, like I said, making a request, waiting for the response, making another request, waiting for a response. Here we only have two functions, so might not be too long, right? That depends. But suppose you had 10 functions, 12, 50, so, you have a lot of this idle time, so you can waste a lot of resources, a lot of memory, on just the function is just being idle. And so for the next two composition styles, I'm going to welcome my colleague, Erwin.
Okay, it works, right? Okay. So I'm going to tell you about the last two approaches, which are basically different from the rest because they require some component infrastructure to use for this composition. So the first one was basically already covered a lot by the last talk. It's the idea of these event-driven function compositions. And the idea is here basically that you have these functions, these events. Functions trigger on events. And these events come from message queues, PubSub brokers like Kafka, NATS, or even the event gateway. And then basically, when these functions are triggered, they execute, they complete, and they emit again an event, this event can in turn trigger other functions. So there's also immediately the main difference between this approach and all the other approaches. Whereas in the other approaches, you really specify the order of your composition of your functions explicitly. So basically, you're stating the control flow. Here, you don't do that. You switch this focus from computation to data. So in this case, here you basically make these functions dependent on data, and by you could say coincidence, these functions emit the data that the next one needs. So in our example, we now have this new component, the message queue, and we set up the functions prior to this to be triggered on specific events. And of course, the client is now emitting an event, which coincidentally is also the event that is needed to trigger function A. So function A is triggered, it runs, it completes, and the event is basically published again on the message queue. And this triggers this exact event triggers the second function because it is triggered on that specific function that function A publishes. So the process is basically that you really get all the luxuries of message queues. Like these are well-tested, well-proven systems, and it also saves you from having to implement all this logic yourself. You don't have to implement the retrying logic, all the communication logic that's associated with delivering messages from A to B. And also the other part is basically you decouple the functions by having them depend on the data. So these functions don't know anymore and don't need to know anymore who or what is creating these events. They just wait for this data. And finally, it's maybe a bit of a catch-22, but this approach is already really popular. Well, the last talk already showed this. But it's a well-proven architecture for doing this orchestration of cloud services, both serverless and serverfull. So there are good answers already to these questions, like when should I use this? What are the trade-offs that you're making? These are things that we already know. The cons is basically also exactly this implicit dependency, because it's nice to show in like simple examples that you can make these chains and they depend on each other. You can understand the structure, but once you get into like an actual system, that's a production system, and you have tens, hundreds, maybe thousands of functions, all having all these implicit compositions in between them, the structure of these implicit compositions becomes very difficult to understand. So it also becomes very difficult and even dangerous to edit or remove functions, because these might be used by some function somewhere else in the system. And then a second point on that is basically also makes it very difficult to actually version and reliably upgrade your functions, because some functions somewhere might depend on some deprecated version of your events or functions. And finally, it also is very difficult. It's not trivial to make more complex control flows. So this training is easy. Maybe the fanning out that the last talk showed is a nice example of this. But how do you actually model things like conditional branching or functions that are triggered when other functions fail? And exactly this is covered by the last approach, which is workflows. So, and the basic concept of a workflow is, it's very simple. It's a directed acyclic graph in which the functions depend on one another. And these And so a function will not start with executing before its dependencies are done. So this looks, in our example, it looks similar as the previous one. We now, instead of the message queue, have a workflow engine or a workflow framework. And the client doesn't actually talk directly to functions or a message queue. It will submit a job to the workflow engine. And then basically the workflow engine takes this job and combines it with the workflow definition it has to figure out which functions to execute in which order. And here you can, in this simple example, it's just first A, then B. But workflows are not any special concept. I didn't think of myself. It's a very common notion. And they are basically everywhere. So there are a lot of domains from business processing to DevOps optimization. And there's also a lot of systems that actually are implementing workflows in these kinds of domains. So to highlight two of them, Argo and Brigade are both newer workflow engines that are Kubernetes native. So there's also, I think they're around here on the conference also. But the reason why there are so many workflow systems here is because these domains widely vary. So all these domains have different characteristics, different users, different workloads, and different requirements. So these systems basically are built tailored to these kinds of domains and to adhere to the requirements and to optimize the performance for the specific domain. And with the very specific model of function as a service, you also get a new kind of workflow. So this is what we call FaaS-focused workflows or serverless workflows, which basically differ from the other workflows because they first need to be fast, so they need to limit their overhead, which is not the case in some other domains. They have to be dynamic in nature. They have to be able to deal with dynamic infrastructure without having any control over this. And they need to be able to deal with many very small tasks that update very frequently. So the two well-known ones are step function logic apps. Those target these functional workflows. And then we have built over the last year Fission workflows, which is basically an open source version of such a workflow that targets these kinds of workflows. So just to dive a bit into Fission workflows, it's a workflow engine that deploys on Kubernetes, and it uses Fission as its function as a service platform. To keep it very short, it basically has two main concepts that it utilizes. So on one hand, event sourcing, and the other hand, control theory. So for the event sourcing, it does not store the state of actual workflow executions, but it stores all the events that are related to the workflow, these workflow executions. So you could say that this, like the last talk talked about this, that these are event-driven workflows. But these events are basically folded into the current state of workflow executions, and the controller constantly keeps track of these, of the state of these workflow executions, and together with the scheduler decides which tasks or functions to execute next. So to give a very quick demo. I have no more than two hands, so I made it that I only had to hit enter. Okay, so we have this directory, and we have basically two functions. The first one is the fortune function, which basically basically outputs some saying, so something. And the second function is basically a wheel that wraps around the input it gets, so stuff like this. So now, of course, the nice thing about workflows, you can compose these functions without actually editing these functions themselves. So what we can do is we specify a workflow definition. We currently use a YAML format. So basically you specify the tasks. So you have two tasks here: input or fortune, and we'll say input or fortune is basically the function called if, which is what we call a dynamic task, which can alter the control flow of a workflow. So in this case, basically it checks if the main input of the request is empty or not. If it's not empty, you will just pipe through the input. And if it's empty, it will use the fortune function to actually create some saying and output that as its result. And then the whale say, as you can see, it requires this input or fortune task to be completed, and it uses the output of this input or whale fortune to for its input. So basically, you can now specify the data flow and the control flow separately from each other. So recreate it, and now hopefully it will work. It's a very long quote, so I'm not going to read it. Or we can just say some input. So to get back to the slides. Okay, so that's the quick demo. If you have questions, come visit our booth and ask me about it. So the pros about this approach is really the single most important benefit of this, I think, is that you centralize all the logic related to this composition. So you have all the logging, visualization, monitoring for these compositions together. And this also allows you to really make these functions loosely coupled, because you completely separate the composition from the actual functions that underlie these, that are actual, implemented functions. And then finally, you also, same as like the message queue, these workflow definitions, as you could see, are very high level, very abstract. So you only define relationships, you define where the data should be at some point. And all the other things, like the messaging, the ensuring that the data is on the right place at the right time, is all done by the workflow engine itself. So, and that if you draw it even further, then it becomes very interesting, because you can now you have full control over this composition as the workflow engine, and you can basically, for example, you can already prematurely start functions to avoid cold starts when you have a chain of functions, for example. The main downside of this is basically that the infrastructure does get complexer, right? Like a workflow engine is pretty complex piece of software, so there might be issues there. But the most important downside is that you need some way to actually express these kinds of workflow compositions in some language, be it like this in a YAML format, or DSL in Go or JavaScript.
All right, so just to recap, these are the approaches that we went over today. So just to kind of sum it up, you can, a great approach is, hey, just do it source code level. You actually may not need a FaaS framework at all. Or you can nest your functions within one another and having them kind of call on each other via HTTP requests, but be mindful of the dependability between them. You can write an additional coordinator function, which will be responsible or give you control of the execution of the sequence of your functions, but be mindful of the time and resources that might cost you. We have EventDriven, which is kind of self-spoken. It's very common. And then Workflows, which is fairly new, which generates a flowchart for you. So I think that's the end. But the big question is, which approach should you use? It depends, right? All of these different composition styles that we presented today, they come with their different benefits and their different downsides, and it really just depends on what you're willing to risk, how big and complex your actual application is. And we actually have a repo that we just put up on our Fission GitHub account. And so that's the link to go and check out and try out some of these composition styles and try them out on different use cases. Also, this was too good of a gift for me not to put in the presentation. So yeah, serverless is lit. Okay, had to. And that's the end of our presentation. Thank you.